Let me introduce Alessia and Damiano. I call both of them on stage, even though each one of them will make a presentation. Please, would you like to approach the podium? Well, I'm sure that you know them very well, but instead me to introduce them in terms of reading what they have done. They have done a lot of stuff, even though they are young, because for me they are very young generation, even though the younger generation considering them, I truly am voted and devoted, because that is our future. But I will start with Damiano because I would like to introduce Damiano. Damiano, you introduce yourself, please.
But I'm special today because I'm the only one having this nice device. So everyone was having the microphone. I have this one.
But nobody's noticed the device because there's long hairs.
No, the only thing. No, the only reason why I have is because I hate to use the microphone. I hate to stay on the podium. I love to walk. I will not walk much because then maybe I fall in the floor. And okay, my name is Damiano Zito. I'm the founder and the CEO of a company named Pro Gold, which is developing, producing, and distributing alloys for jewelry fabrication. Then we have also a division on additive manufacturing, and this will be much also discussed during my presentation today, since our aim, Alessia and my aim, is to try to give you an insight from different point of the supply chain, one in between the refiners and the manufacturers, and another one downstream from Alessia, from the manufacturer side. I'm doing this job from already 35 years. This has no meaning because I love to say that even my father was playing tennis 30 years, but he never played at the level of Wimbledon and that as a professional. So doesn't mean that because I'm doing many years, I'm good. I'm just doing many years. This is what I want to say. And I'm also very much involved on the how to say, the public life of jewelry. I'm part of the Italian Jewelry Federation. I'm on the board, and I have the rights on standardization and innovation. I'm a lover of the technology on jewelry fabrication, not much on watches because I have no really experience in watches, but on jewelry, I founded all my career. I had several chances in my life to speak in front of the people, presenting at the Santa Fe Symposium, and I want to give you, to disclose what we are organizing. We are trying to have to bring ahead the legacy of the Santa Fe Symposium, and from next year, from September 2nd and to September 4th, we are organizing something that we will call the De Vicenza Symposium in partnership with Legor. That is our main competitor, but this is nice that we do something together, and Italian Exhibition Group as a sponsor. It's too long presentation. And Alessia, now is your time.
Thank you very much. Come over here to Alessia. The microphone is yours.
Okay. So I'm Alessia Crivelli from Crivelli Company, placed in Valenza. My company is a family company because it's founded by my father 50 years ago. So, and he's still here. So if you can come to all 7, you will find Bruno on the stand. And I love jewelry as my father loved jewelry. So I start my journey in jewelry business when I was 20 years ago. When I was 20, 20. So 23 years ago. So
nice.
Yes, and so I still fall in love with my job, and I still fall in love with my system, with my colleague, with the challenge we will find every day. And I'm in the same association, Federography, and I'm in charge of education. So I'm fall in love also with the young generation. I think they are amazing. So I will speak about this after. So I don't want to annoy you, and that's could be my presentation. So I broke the ice.
Thank you very much. So now I give the floor to Damiano
thank you
for
very
his
much.
presentation.
So-
Thank you very much.
We have something like 254 slides, so if we have time. So let me start just reading the title. So we were asked to give you an insight about our experience, our daily experience. So, and see which are the issues and challenges on the use of gold and other precious metal in the everyday jewelry design and manufacturing. So what we are bringing here is an insight. We do not bring you graph or numbers much, but only the everyday experience. The presentation will be divided in 4 points. Me and Alessia, we are going to jump to different slides, and some slide I will speak, the one more technological, and the one more, yeah, Alessia will speak about. So we will start from ethical sourcing and sustainability, not at the deepness that all guys you today were talking about. So we will just give you a point of view from really from the bench, from the goldsmith bench. And then we will go for the technological innovation, talking about what are the today technology, the most common used, which is the disadvantages or the advantages, how are the technology impacting from the, how to say, how they are impacted on the gold, for example, from the gold price, and how they are impacted from sustainability point of view, and also which is their carbon footprint if we go in deep to see. And then Alessia, much more here, will talk about the economic and market challenges. So what is happening on the from the bench when the gold is going up and down, how the orders are changing or what is happening from a manufacturer point of view. And then we go to the end, talking about the future trends and opportunities with a very important focus on technology, but also having also a point of view from, for example, the educational side that Alessia will talk about. So we start from the ethical sourcing and sustainability. Now is the time of Alessia. I will. Gelato. You see that I was more wise?
Okay.
I was wiser.
No, okay. So I focused my very quickly speech on the importance of historical and economic role of gold in jewelry. Because if you think about jewelry, immediately you think in the first image is gold, and this is from the beginning of our story. So you can recognize a queen from the jewelry she had. You also in the economic part, for example, money, the coins. So that's one of the most important thing. That because gold is not for me. I'm a brand, so I have to explain the importance of gold, and I have to try to give some answer to my customer for the increasing of prices. And obviously they will find a ticket different, and I have to explain them, and that's very important, because gold for us is not price, is a value. Okay, and this one of the most important things. I focus also on the creativity and economics in the production process, because for us, creativity and economics are very important. They are the best. How to say in English? Che sono sono sempre stati il duo su cui noi abbiamo sempre lavorato.
Okay, ask someone from UK.
No, okay. I try to explain another way. Now, our final customer, because every day I receive some question from my final customer in my customer service, and they ask me something regarding the craftsmanship or the stone, or they ask me about sustainability and transparency of my items. So that's important. That's the changeling for us, and I think also is the challenge that we have to answer to our customer, in my point of view.
Okay, next one.
Sei tu?
No, ancora tu.
No, fai tu.
Do you want?
Tu.
No, say tu. Okay, never. Okay, never mind. We wanted to highlight here the fact that from the manufacturer perspective, the job that is done by John, for example, at ISO 174, or every organization that is trying to develop a standard and give a clear understanding and meaning of a word. Now they very much use it, but not much understood, because finally the greenwashing is really something that I will say that the people should work ethically and not promote that they are really working ethically. It's like that you say that you do charity. Is important to do charity or to say that you do charity? The only reason that we say that we do charity is just because maybe we influence other people to do the same. But finally, we have to arrive on time just because it's that way that we have to behave. It's not because we are good that we arrive on time. And the same thing, talking about recycled gold, recycled silver, or any other materials from the manufacturer point of view is more than important, because is finally if there are no how to say description of the understanding, then every player in the market is playing in a very singular way, and they take advantages on this. And this is something that with Alessia, we were talking about, because we have not to go deep. So what is our feeling? Not at the point of the supply chain where the company I'm running is working, but where Alessia is working. If you want to add something more.
No, it's correct, because the important the importance of a certified supply chain is something we can communicate to our customer. And when they ask me or ask to my colleague or to other brand some question, we can be clear if we are all in a unique supply chain. That's important. In that way, we can be clear, and we can say the truth. And that's very important, because the final customer asks the truth in this moment.
Let's move to the technological innovation. I wanted to give you an overview about which are the technology much more used for producing jewelry. Today, almost 85% of jewelry is produced by using investment casting process and CNC machining. The last one, the CNC machining, is having a very important traction in the last 10 to 15 years. It is still a typical technology used to producing watches, but since the ability to work some much more complicated geometries made the technology very attractive also for jewelry. And those two technologies has won several strengths, like surface quality, the surface smoothness, the production capacity if we watch on casting. But from sustainability point of view, so from the ethical side, they are not really very green. And we can see this from the next slide. When we see about which is the yield in using, for example, a company that is having an output of 300 kilo, 200 kilo of jewelry produced by CNC machining, they have to start from 1 ton. And when they start from 1 ton, then they go down to 20 to 40%. And this is the yield they have. Then they produce chips. But those chips in high-end jewelry manufacturing are not remeltable. I mean, you can remelt, but then you can have the possibility or the risk to have a contamination by the machining tools containing tungsten or many other carbides or metals that are really not soluble in gold, and they give a very common defects called hard spots. So one issue is that when you go to refinery, then there is a lot of metals that you are losing, or in somehow there is a chemical involved, and finally the carbon footprint of that process is very heavy, and then the quantity of inventory. So according our how to say investigation is that if someone has exactly an output of 1 ton per year, then he has to have an inventory quantity between 300 to 500 kilo every day. And this is really something that for CNC machining is a quantity that you can't escape. In case of investment, casting is not that capital intensive like it is for machining. But in terms of high emission of CO2, so the carbon footprint, try to image the investment casting process, start from the master model, then you produce the wax pattern by injecting or by 3D printing, then you do the tree assembling, and then produce the investment flask, then you burn out the flask, and then you pre-melt in the alloy, and then you cast the metal and you cast the tree. This is 8 phases. But the most critical one is the burnout process. What we are doing in jewelry is that we all every day have a lack of gold. Is the most important resource, but we never have enough. And this, what is happening, we do produce according the quantity of gold we have, not according the order we have, or according which is the most convenient productivity guidelines. So we have 50 flasks to cast this week, so we cast on Friday. No, we cast 10 flasks every day. So it's like to have a plane, instead to have a fully booked seats, then you go and take off with only 20% of passengers on the plane. And this is really very much impacting. The technology will not really, the technique will not really be very having a big impact in terms of carbon footprint, but is the, let's say, misuse of the technology that is not really much helping. And then there is another limitation, that there is no possible to tune in the weight. So in jewelry, we have 2 possibilities. Or we make the solid jewelry or the very light jewelry through electroforming or through any other process involving very thin sheets. But doing something in between is very tough. So this to help on having this possibility will be another technology that I'm talking about later. Now, all these things, in somehow, they are impacting on, they need gold, and gold price is growing, and then they are not really, they have both a very high carbon footprint value. So already in the last 15 years, a technology called powder bed fusion was getting more and more used in jewelry. It didn't take a very much traction because it's used very commonly for very niche collection, especially to produce 2 advantages. Here we have, this is the laser, yeah, but it's not working. The limitation is the resolution. Another limitation is the production capacity. But in compared to the previous 2 technology, the carbon, the sustainability is very high, because there is a single phase from the design to the part. And starting from a metal powder is not much different than starting from a pre-melting 18-karat casting grain. So there is a difference in terms of energy involved to produce powder, but not much, as the people maybe could think. So the advantages of the technology is mainly that is opening new geometries avenues, but the most important thing is the weight tuning for two main reasons. For marketing positioning, because you have a ring that is the designer is making a ring. The weight is 15 gram, but then you need that ring at 13 gram without changing the apparent volume. And how to do? Then you empty inside. So, but you do not make super hollow. You just make a little hollow. And this is something that you can do only with additive manufacturing. On the other side, you have something that is too heavy and maybe it's 70 gram, 80 gram. And then for wearability reason, you need to drop to 50 grams. And when you drop to 50 grams, you have two choices. Or you do separate and then you assemble. But when you assemble, you have the soldering line. And this is an issue on high-end jewelry. Or you do empty through that technology. And the emission of CO2 is really much lower. So here we have an example of a paper that we were presenting already 6 years ago at the Santa Fe Symposium on doing a calculation and comparing direct casting with powder bed fusion is also called selective laser melting or also direct metal laser sintering. For a single ring of platinum 950, the additive manufacturing, so the powder bed fusion was producing 261 gram of CO2 in compared to over 600 gram. And these didn't count all the energy or the environmental impact to dispose the investment. You have to consider that every 2 to 300 gram of casted part in jewelry, you have 2 kilo of investment. So you made that investment, you need to treat or to do something with that investment. And it was not considered. This was only the energy needed for making the entire process. But it's quite intuitive. A single phase process is really need much less energy than a process, or you even risk to do not have efficiency from every single phase in compared to casting when every single phase has an yield and you misuse the energy in every single one. Then another things that is also that is also taken into consideration at the point from our point of view in the supply chain is how to use the artificial intelligence. We were also presenting another paper at the Jewelry Symposium this May in Detroit. And we were talking about, we were taking all the last 20 years data about the physical, chemical, mechanical, and technological characteristic of all the alloy that we have in our range. And we use for machine learning and try to predict the mechanical, those characteristics for a new composition. So starting from another recipe, which will be the characteristic. So the characteristic that we were checking was the color, the viscosity of the molten metal, the melting range, the tensile strength, the heat transfer, the elongation, hardness, and deep drawing. All those characteristics usually it takes something like 15 days for an R&D person to do the characterization. So because we have to prepare the sample, to measure every single characteristics, and it has a lead time of 15 days in compared to a simulation time of a couple of hours. And the standard deviation was something very interesting because in case of the solidus temperature, the difference between the real one, because after we were even measuring the data, was in the range of 2 Celsius, on the liquidus temperature 5 Celsius, on the tensile strength 10 megapascal, according the real value and the simulated value. And in terms of the, what was other characteristic, the hardness, the melting range, that's all. And in terms of another topic of today, which is the carbon footprint of characterization of an alloy. So you have to melt, you have to use gold, and then you use energy, and then you have an impact. In that case, it's like writing letters, or sending email. Of course, even the email has a carbon footprint, but a letter has maybe much more. So this will be really another advantage. The future development in this case is something that we will really work and do, is that starting from a specific characteristic like the melting range or the specific color or the specific mechanical property, we go back to the recipe. So we get back the chemical composition of an alloy. But this doesn't mean that we will stop doing the characterization, but instead to start a process of developing an alloy and having 20, 30, 40, 50 candidates. Then we will have just two, and this will have an impact on the environment. And this is not only nice things, marketing or that thing. This is something that really work. And we started from a scientifical side, and then right now we are really having the possibility to take advantage from this. I wanted to show, this is the last one, that last example of the technology that we love to explore. There was a very nice case history when Bugatti was developing his model called Veyron, and they were doing the crash test, and they were destroying 16 Bugatti and not having results. And 16 Bugatti, the cost was 2 million each, so 32 million. And there is a very nice post on Instagram where the CEO of Bugatti, the CEO of Dallara, that was a company that is doing simulation of the crash test. So they started to collaborate, and then they were working with the engineer of Bugatti, and they were changing something on the project, and then they built another car, they made a crash test, and they passed it. And the question was 2 million versus 32 million, and he said, which will be the invoice that I have to give to Bugatti for this service I was giving to them? So this is nice. And what can we do in jewelry? And there is some tools that we are not using, like the casting simulation. It's already 20 years that casting simulation is in the market, but which is the reason why it's not very much used? The very important reason is that to make that system working, that model working, you need data. And to have data, you need the physical characteristic of an alloy. We have equipment at our R&D department, like measuring the liquid alloy viscosity is not something easy, or measuring the shrinkage of the alloy from liquid to solid is not nothing, or measuring the solid fraction during the solidification and the liquid fraction. All these data make the prediction very close to reality. And what is changing? The time to market is very short. The number of flasks that you do is much less. So all has an impact. But maybe 20 years ago, the number of data available, the number of physical characteristics were not available. And that was the reason that it was only something very nice to see, the simulation, but it was not a device, an instrument predicting where the porosity was going to be. And this is really an important tool. Now is your
Okay,
time.
so that's my part. So, in according to Damiano, I want to show you this. This is a bachelor, is correct? Bachelor, yes, from a student from IED in Rome. And she's a woman. She's preparing her bachelor, and she decides to prototype. You see, her first collection. What I want to show you, and I want to put your attention, is for our young generation. This is normal. So they use AI and they use virtual reality. They use all the the innovated instrument we have as a normal thing. We are still thinking about how we can use it, what is the better way to use. For our young generation, that is normal. And the result, I saw the bachelor last year, and the results were amazing. So they created, I think, final product and final jewelry very amazing. So I want to show you this also because it's normal for us using this kind of process in the school. So in the education of our young generation, we use all these instruments, all these programs. For example, CAD, for example, not reality, virtual reality, augmented reality, yes, because they can create a ring, for example, and they can see the ring without a real prototype. Okay, so that's a very important thing.
I think that this one we jump over.
Yes.
This was your economic.
Okay, this is mine. So this is a graphic, the only graphic we have, I think. And you can see the cost of gold and reached very high levels. So that could be a problem for us. And what I said in the beginning of my speech was that this is not a price. This had to be a value. So what we try to do with our customer, in our experience in our company, is to communicate the value of the manufacturing we sell. And not just we sell, we produce and we create. So gold is one of the main important part of a jewelry creation. So inside there is a very important great material, but also there is the creativity of a man or a woman. And there is a dream before. There is a lot of work in a very amazing and very strong supply chain. Because when I have a new idea, I want to create a new collection, I asked to Damiano, what is the best way to produce it?
What? The best
If
way?
if I have an idea and I have to produce and I want to be sustainability and I want to do the best practice, because this is our meaning of supply chain. I try to explain to you. I'm sorry if I make some mistake. It's my first time, so I'm sorry. I used to speech, but usually I do in Italian. So I have the concept in my mind, and I'm trying to translate to you. Sorry. So that's to say that production process is one of the most important thing in our job. Okay.
The one that we go to this one.
So final customer demand more. I told you before that my customer service receive a lot of email in which final customer ask a lot of things regarding the items. And my company is a link of a supply chain. And when I say something to my customer, I'm not speak just for my company. I'm representing all the industry. So that's one of important thing. And communication and information is another point, another challenge, because we used to speak about our industry throughout the items we sell, throughout the communication. But it isn't so. We have to learn to speak about the history behind the items. We have to speak about our production. We have to speak about our research to ethical sorry. So yes, okay. So that's another important thing.
Okay. So, so we talk a little bit about, and this is the last key point of our presentation about the future trends and opportunity, and we go to explore more from the technical point of view. In terms of additive manufacturing, the technology that personally I'm very much fascinated, and is, in my opinion, it will be really the the one technology that will make the additive manufacturing being totally embraced in jewelry manufacturing. And I'm talking about nanoparticle jetting. There are, I would say, three different technology that are commonly called 3D printing or 3D metal printing. One of these one is the powder bed fusion that is using a powder bed that I spoke before. A second one is called binder jetting, that is always having a powder bed, but is a sintering technology. And that technology has the same limitation like powder bed fusion, very high production capacity, but the surface is rough. But nanoparticle jetting is totally opposite. Like a printer that we have in the office is using an ink, and the ink is spray on the building platform. You don't need a huge amount of metal. So we are talking about precious metal. The less the the gold immobilized and the better it is. And using nanoparticles, the resolution is amazing. The level of roughness is something like 20% lower than investment casting. So investment casting, in my point of view, is quite smooth, and that one is really much lower. The production capacity, let me put, the production capacity is quite high, not as binder jetting technology, but we are in the range of from 3 to 500 kilo a year for a single printer, which is a decent quantity. I will say that if you go with a binder jetting, you go even 5 tons a year, but then it's something rough. And the problem of something rough is not that the goldsmith takes longer for polishing. The problem is that when you do intricate jewelry, how to go in every single detail and part. So you can print, but you cannot finish. And this is an issue. On when you have a surface quality comparable to investment casting, then you are at the same level of the state of the art. So if they do in casting, they can do also nanoparticle jetting, reducing very much the gold inventory for one reason. What I'm personally dreaming is the combo used with the CNC. So I love, and not me only, but all people, all visionary, or all the early adopters on additive, they love very much to think about additive manufacturing as subtractive manufacturing. So AM together with CNC. In the market, there are a few systems that are using combo. So a powder bed fusion unit with a CNC inside, or a wire unit with a CNC inside, but it's for industrial application. No one is developing a small system for jewelry that is taking care that we are using precious metals and we cannot lose precious metal during the process. So having together, you can really go to feed the CNC machine with a near net shape parts, just zero point 0.2, zero point 0.3 millimeter thicker, and then go for a CNC machining for a very last mile to get the final products. But someone could wonder, but for what reason don't we do by casting? So we do the casting, then we go to CNC. The reason is that the casting has a limitation on the dimensional accuracy. So every single parts when you put in CNC is a little bit different, and then CNC is getting crazy in this and doesn't work. So what the expectation of nanoparticle jetting is exactly that is very stable in this and is going to that direction. At least it will be able to be a complementary technology with investment casting, but much more sustainable. Of course, it's a sintering process. It's not as nice like powder bed fusion, but it is much more efficient in compare to investment casting process. And you can go with all the advantages for the smart hollow parts, tuning the weight, and many other things like exploring new avenues on materials. Because when you have a powder, nano powder, mix it together, you can even think to make metal and ceramic together. And this is opening a possibility for future jewelers to have higher strength material, something composite material that you cannot do by melting and casting, or what colors, or many other stuff. And that's why it will be very, very important, in my opinion. The industry. I remember I was at the 2017 Santa Fe Symposium. The people were asking me, "Oh, but what the technology has not ready yet to make the people start in use?" I do believe that the technology is really like a piano. Is always the same in the last 400 years. But then maybe the people now are playing much better. Or when you start, you play so and so, and after 10 years, the same piano, you play much better. So 3D systems are something that maybe are the people, like always, not ready to embrace and go ahead and use it. Another nice technology, but this one is something that, in my opinion, is compensating the lack of human resource. And maybe Alessia will help me. One very critical point in jewelry is that there are no young people. A goldsmith wants to, and something very nice. One of the reasons why CNC was taking traction was always also because of the complexity of the things that it can do, but also the fact that you really, for many production, you don't need very high skilled goldsmith, because you have not to grind in the parts, because CNC is doing. Then you have just to do the final polishing. So there is this technology that it was, of course, maybe in watches is used very much, but in jewelry not much. That is amazing. It takes few minutes to train. You have not to write codes. You teach how to polish to the robot, and after 10 to 15 minutes, you are able to polish a parts. And then you put in memory. And this is really something that, for not all, and we have to, the industry has to stop about the concept that a new technology is substituting an old one. No, a new technology is complementary to the old one. So we jump to the conclusion. So start with your
So
first.
I have some part of my production that maybe I can start to use CNC machine. So I have, now I have. My production is still as manufacturing, we use a lot of very precious stones. So we create sometime, much there sometime, we create the ring or the necklace or the earrings around the stones. So we start from the stone and then we arrive in the final item. So this is a innovation, and I think it should be a part of future of our industry,
Sure.
and that's okay. So what I want to say you in my conclusion is that we have a very interesting and amazing young generation approaching our job, our work. And we have in Valencia, we have a foundation that works with the young generation, and we are 50 companies, some very important companies inside. And we are working on the attraction on our beautiful world, because sometimes the young generation, they don't know the reality. They don't know our business. They don't know our world in the complex, in a complex way. So we start to work with them, and for me is an honor, because usually we start to speak with them, and we decide to we try to teach them something about our work. But I completely changed my point of view, and I started to listen them, because they are incredible. For them, I told you before, they use AI, they use the computer. They are completely open mind. They want sustainability. They want the inclusion. They are amazing. So maybe if we are here and we are speaking about the future of our industry, but for us, but I think that we have to do this also for them, and we have to have them here next time. I try to I want to tell you, if you want to invite some young generation or young designer, because if you listen them, they can open a new image of our future, and that's important. I try to explain my better.
No. The only few words at the end is that we were today afternoon was very much focused on gold price, sustainability, recycled material, and our part was to say that there are technology to mitigate the issues on up and down of gold. There are technologies to try to have a less impact, and this is something that really we do believe that jewelry industry has to try to understand one very crucial point. In the past, the time of R&D was very clear. This time of industrialization was very clear, and then the product in the market, the moment was very clear. Now is confused, really. One is crossing over the other one. So the industry has, you have to understand,
Yes.
so the industry has to understand that you have to enter with a new technology when it's still not ready.
No. We have to try.
And I do really believe in this, because if you wait that it will be ready, then it will take much longer and maybe it will fail. Because then the only advantage to have the people using is that when the people use, they complain. And when the people complain, someone take care of the complaint and they try to fix. Thank you very much.
Thank you. Grazie.
Thank you very much, Damiano and Alessia. I would like to ask if there is any questions for them. Please.
Great presentations, by the way. Thoroughly enjoyed it.
Thank you.
In my past life, I was a manufacturer, and we had a reasonably substantial budget for technology and investment. Now, in the UK, I've always found that the problem with advancement in the jewellery industry always comes down to the lack of funds, and new technology is very, very expensive. So how do you equate the two?
May I answer frankly? Even people that has money, they don't go for investing. So I do not think that is an issue. I mean, I do believe that if you believe in something, you find a solution. The thing is that if you want to have the money ready to invest money, then the lack of fund, I think, is something that you can really afford today. I mean, if you really do not have a part of fund to grow, to develop, then you already decided, oh, okay, I'm the follower, someone will be an early adopter, someone will be an early majority, and then I will be a laggard. Maybe I'm a successful company, but one day I will be any more a successful company. So I don't believe that is a matter that the technology is very expensive. Again, I was joking before, but really companies that has resources, it is an attitude. It is an attitude. And it's really, but it's something that the people has inside. You see that the one that has the attitude has no fun. The one that has the fun has no attitude. It's like in Italy we say the one that has teeth has no breath, and opposite. The one that has breath has no teeth. I don't know what to answer more, that I do not believe that is a matter of fund in general, exactly because companies or organization that they wait for the time that the technology is ready. It's like to have a baby. And I wait that he will be 20 years old because when he's not sleeping the night, he's up, how to do. But he's a baby and he's not giving you satisfaction when he's young. He's giving you only trouble, especially when he start. I do not have child, but in the general meaning, in the general,
In Italian, we say small kids, small problem. Big kids, big, big problem.
yeah, but then
Believe me.
they are not understanding that they. So you can. I mean, I do believe that the new technology is like a baby. You have to take from the hands and go. And it's not giving you results now. It will give results. If you do not have that attitude, the thing is that it is very, how to say, complex to survive in today business. This is my opinion. I'm sure I didn't answer. I'm really sorry.
Thank you very much for speaking about artificial intelligence. I suppose we spoke about it in Las Vegas. It was one of the biggest issue, because you had people against. And at the end, you could learn that you can gain time, you can gain productivity, but you can also be a real craftsman. It's not a problem. But speaking about nanotechnology,
Yeah.
for me, it's not the price of the machines who is a problem. It's the technology itself. Because when you talk about nanoparticles, you have density of the materials. So is it are you able to use alloys because you have a certain different density, and also all the atoms are not the same? So it's, for me, it's quite difficult to make. It's challenging to do ceramic, for example, and gold. But do you have to use for the moment only pure gold because you can't use alloy? I don't know.
This is a technology that is going to come. I mean, technically, we are working with a Israeli company, so it's mainly there that they do this job, and they go for nanoparticles already on AZ 316L, and it is already in the market. Okay, they do also zirconia, but this is maybe more common. But they go for the alloy, not for the single elements. So they don't go. And nanoparticle is something bit marketing, because finally the D90 of the particles is 3 to 4 microns. But what is very nice is that the layer thickness of every single layer is around 7 to 8 microns compared to the 30 to 50 micron used in binder jetting or powder bed fusion. This is dramatically dropping increasing the resolution. But what is the problem? Someone say, for what reason I don't go for powder bed fusion or binder jetting down to very small particles? We have another paper presented in 2022. The issue is the flowability. When you have the powder bed and you have the powder that you spread in the building platform, there is an issue that is not possible to make a very consistent layer because the powder doesn't flow like a water. In case of nanoparticle jetting, you have no powder bed and you just spray, even in a big platform, a single ring. In the other cases, if you have that platform, for example, in binder jetting, I know a company that they have something like 45 kilo of platinum, how to say, immobilized in the 3D printing machine. So to say that there is really not nanoparticles, so a few fraction is nanoparticle, but is very low micrometrical powder, but much more than enough in terms of resolution, surface roughness, which are the only two things that a goldsmith is against of. Because a goldsmith, when he sees something rough, he says, oh, this is porosity under, put on the side. No, put back on the crucible, melt, and send to refinery. This is what they do. So I hope I answer.
So the bottom line of this joint presentation, in my opinion, is just to be very pragmatic. is the following. Number one, there is not enough gold. So, ladies and gentlemen, please supply more gold or more platinum or
But
more
this is
silver.
amazing. From the very rich company down to the small company, everyone has, they have a lack of gold. Only refiners maybe has gold. They keep too much, they don't give for they do not lease enough.
So evidently this is a fact. So please move on. That's number one. Number two, innovation and technology. CIBSO has an innovation and technology committee since several years. And let's say we are doing a lot of stuff, including education, but I will tell you afterwards when I will make a very brief presentation of what CIBSO is and does. But before doing it, if there is no extra questions for this lady and gentleman, I would like to thank you very much indeed.
Thank
for
you,
your
Alessia.
great presentation.
Thank you. Thank you.
Thank you very much indeed.